So we are going to talk about the trigonometric functions. Now, by trigonometric functions, we are referring to relationships between two variables. Okay, and usually the variables are x and y. Okay, but in trigonometry, sometimes the x can be replaced by theta. Okay, in most cases, the x can be replaced by theta, right? And the x, we call it the independent variable, or we call it the input variable. Based on what you were taught last year, it was called the input, okay? But it's also called the independent variable. The y is called the dependent variable, or we can call it the output variable. Right, so generally, a function is just a mathematical relationship between two variables. Okay, it's a mathematical relation between two variables, and it can be represented, or you can illustrate that relationship as an equation, and that equation can further be represented as a graph. Okay, now here we are only going to concentrate on the graphical part. Okay, so the trigonometric functions, they can be represented as a graph. So we've got three types of graphs because of the three trigonometric ratios, that is sine, cos, and tan. We also have their graphs, that is y equal to, well, let me use x. If I say y equal to sine x, y equal to cos x, and y equal to tan x. Now those three basic graphs can further be analyzed. Either you can shift them up or down. At this stage in grade 10, we only shift them up and down. We don't shift them in a horizontal direction. Okay, the horizontal shift, that's for grade 11. Okay, so just copy those points down. Then I'm going to introduce some very important concepts after that. Now your domain is a set of all the x values. Is a set of all, well, I'm saying x, but sometimes it can be theta. So it is the set of all the independent values. Okay, the set of all the x, in brackets here, I'll say theta. Okay, I'm putting theta because we are dealing with, we are in trigonometry. Okay, generally we interchange those two, that is x or theta. If it was an algebraic function like the linear and the other three that you are going to learn about, there's no need for me to put theta. Okay, then we have what's called the range. Okay, it is a set of all the y values. Okay, so your range is the set of all the y values. Please, the way the range has got many definitions. Okay, in statistics, it's maximum minus minimum, but that's a definition in statistics. When you're dealing with functions, it's the set of all the y values. Okay, so with the domain and the range, what we are saying is we want to know what is the minimum value of x, what is the maximum. Okay, we also need to know the values between the minimum and the maximum. That's why we have got this word here, the word or. It means we are talking about every value of x or every value of theta if you are dealing with the independent variable. Okay? For the dependent variable, we are also talking about all the values from the minimum to the maximum. Okay, so all the values between the minimum and the maximum. Sometimes the minimum and the maximum can be included or they can be excluded. But when you're talking about domain and range, we have to include them. Okay, So they are part of the set. That's what this word all means. Which means if you are using interval notation or inequality notation, you have to include the equal sign or you have to use square brackets. Okay? But if the minimum is minus infinity and the maximum is positive infinity, you don't use square brackets. Okay? And I'm going to remind you about that. And then the other term, or rather the other aspect is what's called function notation. Function notation. Function notation. In trigonometry, or rather in this grade, you will be introduced to a new concept, which is the concept of function notation. Okay? In grade 10, okay, y, we can say from grade 10, in grade 10, y is replaced, okay, I will use the word sometimes, is sometimes replaced by, y is sometimes replaced by f of x in brackets, like this, right? Now, when you are dealing, we say f of x if the independent variable is x. Okay? If the independent variable is theta, then it becomes f of theta. Okay? Now, f of x, okay, is pronounced as, so right here, f of x is pronounced as f of x. When you say it, okay, when you say it, you say f of x. Right? Please take note. We have got two ways of writing our independent variable. Either we can use x or we can use theta. The reason why I'm talking about both, because I don't want you to say, okay, if I teach you using x, then you see theta later, you say this is fundamental theta about theta. You need to know that for trigonometry, there is an interchange between x and theta. Right? So here, if I write f of theta, is pronounced as f of theta. Okay, so I'm going to write that in using a different color. So you can have both of them. Right? F of theta is pronounced as f of theta. Okay. Right, so I think I could do the introduction then. Let me introduce the first graph. So, I'm going to talk about function notation as I get on with the trigonometric functions. I'm going to be reminding you about it. It's a very important concept in math going forward. Right? Or rather, let me just write to give you an example. E.g., right, uh, in grade 9, when you're doing the linear function, you're writing it as y equal to mx plus c, like that, right? Now, from this grade, you need to know that sometimes the y is replaced by what is called function notation. So this can also be written as, f of x, where x is our independent variable. It will be equal to mx plus c. Okay? You don't have to get confused because all we are doing is just replacing this y here by f of x. That's all. Okay. So what that means is f of x is y, f of theta is also y. Okay? So I can say therefore y is equal to f of x. In trigonometry, y will be equal to f of theta as well. The right hand side of the equation does not change, but the left hand side can change based on the use of function notation. And that's the most common notation used in mathematics from grade 10 going forward. Okay. Right, so let me introduce the first graph. All right. First thing, we'll start with the basic graph. And the basic graph is y equal to sine x. I'm going to use x instead of theta, right? So we'll start with, I'll call it number 1, right? Y equal to sine x. Okay, that's our graph. I can write that as f of x equal to sine x. But for now, I'm going to start by writing the dependent variable as y. Later, I'm going to replace the y by the function notation. Okay? Now, I can sketch this graph, but just want us to do a short exercise. Now, generally in grade 10, we will sketch the graphs of trigonometric functions from 0 degrees up to 360 degrees in grade 10. So we only concentrate on the positive values of the independent variable. Okay, and our independent variable here is x. So if I, okay, let me just draw a table of values. And you also need the table of values. Right. I'm going to concentrate on key values of x. So we have x, then we have y. So we have 0 degrees. Then, well, I'm not going to put the smaller ones like 30 and 60. I'll put 90 degrees, then 180 degrees, 270 degrees, and then 360 degrees. Now, if you use your calculator, right, where there is x there, if you put 0 degrees, you will get 0. The y value will be 0. Sine 0 is 0. Then sine 90 is a 1. Sine 180 degrees, it's a 0. Sine 270, that's minus 1. Sine 360, that's 0. Okay, you can verify that with your calculator. Okay, then you have to use that table of values to sketch the graph of y equal to sine x. So to sketch it, so let me calibrate it. All right, let me put 180 degrees here. You must use the ruler. You must use the ruler. I don't need a ruler. So this is 90 degrees. That will be 270. Somewhere there we have 360 degrees. Okay? And for now, our amplitude is 1. I'm going to define that maybe in the next lesson. So the minimum of -1 is, you can see that, and the maximum is going to be a 1. Then I have to plot my point. So when x is 0, y is 0, which will be there. Right? And then when x is 90, y is 1, which will be somewhere there. And then when x is 180, y is 0, there. And then when x is 270, y is -1, somewhere there. Right? When x is 360, y is 0, it will be there. Now, the graph of y of sine theta is not a straight line, it's a curve. Actually, it's called sine curve. Okay? Have you done waves yet in physics? Okay, you're going to do waves later. Okay? So when you schedule, use freehand. So you're going to have that. So that's the graph of y equal to sine x. Okay? Now, from here, I'm going to define some very important terms. Right, let me. Okay, this distance here from the x-axis to the maximum turning point is called the amplitude. Okay, the distance from the the x-axis is also called the equilibrium position. Okay, so this distance we call it the amplitude. It's always positive. That's the amplitude. Okay, and this is also the amplitude. From the x-axis to the minimum turning point, that's also the amplitude. Okay. The amplitude is the height of a crest. This is a crest. Or the depth of a trough, which is that. Okay, you are going to need to know that as well in physics, because we are going to do waves later on in this year. There is some relationship between trigonometric functions and waves in physics. Okay, so I'm going to repeat that. The height of a crest is amplitude or the depth of a trough. Okay, and amplitude is always positive. It's a distance. Okay, it's never negative. All right. So from here, so we've got our amplitude, right? Then the distance in degrees from the origin here up to 360 degrees. That distance is called the period. Okay? The length of a full sine curve is called the period. So the period here is going to be 360 degrees. Now in maths, the period will be in degrees. In physics, it won't be in degrees. Okay? So I don't want someone to get confused later on. In physics, it will be in seconds to be time. Here, it's in degrees. Okay, so I think I just need to define amplitude and then period. But I'll carry on next time we meet.